Hey all, Professor Wyman here, and I'm going to talk about how to conduct the chi-square test for independence in Jamovi. This is also known as the chi-square test for association. So the chi-square test example I have, is there an association between first generation status and reaction to pop quizzes? So the reaction to pop quizzes is panic mode, Zen acceptance, or dependence on the situation. We have three categories. And then first generation status is yes or no. So we have two categories. So for chi-square test for independence, we're looking at two categorical variables. And the key between them is that we're talking about are those variables related? So do more people identify as reacting in Zen acceptance that are first generation students, for example, would indicate a relationship or an association. If there is an association, they are not independent. So that's how those terms relate. So for this example, I'm going to go ahead and go into Jamovi and go through the steps. And I'm going to also, in later videos, talk about how to interpret the contingency table and the chi-square test. This is a non-parametric test, but I am going to talk about some assumptions that we can test. So here we are in Jamovi. I'm going to go up to frequencies, and I'm going to choose independent samples, and this is the chi-square test of association. So you can see that it sets up a contingency table. So the way that I learned it and the way that I typically see it is that the more likely independent variables, the more likely cause is going to be in the columns. In this case, you either are or are not first generation status. You can't, like, the way that you react to a pop quiz cannot have an effect on your first generation status. So that's going to be the natural independent variable. So I'm going to put that into columns. And so that means that we're going to have two different columns for first gen, no, and yes. Then I'm going to move the pop reaction to rows. And I also like just having two columns across the top. So if I think it works better too. But you could do it the other way. Now, this gives us a contingency table with our observed frequencies. So observed frequencies are what we are observing in our sample. And that's what we're comparing. The test statistic, the chi-square test statistic itself, is a calculation of how well the expected frequencies match the observed frequencies. So what we can do is we can actually look at that. And you can click on various things here. So you can go to statistics. Changing the hypothesis doesn't actually change anything, so you can ignore that. But we can add a phi and Kramer's V, which is the effect size. The phi coefficient is not going to show up when you have more than a 2x2 table. So this is 2x3. We have one variable with two categories, one variable with three. So that's a 2x3 table. So we would use the Kramer's V. And then I'm going to go to cells. And you can see here that we have this observed counts checked. And I also am going to click on the expected counts just to show you what that looks like here. So what this would show us is if we had an equal number of people in who are non-first generation across the different panic modes based on a percentage of our group, then we would expect to find around 4 people who were panic mode, who were not first generation, and we actually had 5. So that's the comparison there. So the chi-square test statistic is actually a combination of that information. So I'm gonna unclick that for now. That was just to kind of show the information here. And then I'm going to click on this column percentages. So if your independent variable is the column, you should do column percentages. If the independent variable is your row, you should do row percentages. You can make your life complicated and click all of them if you want to. It's a lot of information, but it also, if you're comfortable with it, it can be helpful. So that is how we calculate that information. I am going to, in the next video, talk about assumptions for this test, and then I'll talk about how to interpret the results. So I'm going to go ahead and stop recording here and then pick up with the assumptions testing.